Welcome to 502 Conversations. I'm Brian Kirby. My guest today is Abby Hafer. Abby is a zoologist, and you currently teach anatomy and physiology at Curry College.
That's right,
correct?
yes. Mm-hmm.
And you've written The Not So Intelligent Designer.
Right.
And you have a new book out, Darwin's Apostles.
Right.
All right, I'm going to read your bio, and then we'll get into it. Because I always read the bio because I think it's kind of interesting, and I like to get people's credentials out there. Because at times we're acting in a society that doesn't value expertise all the time, so I like to make sure people know exactly who you are. Is that all right?
Sure.
All right. Abby is an author, a scientist, educator, and public speaker. Her book, Debunking Intelligent Design, The Not So Intelligent Designer, Why Evolution Explains the Human Body and Intelligent Design Does Not, became a #1 bestseller on Amazon in the category of theism, of all things.
Of all things.
Her public speaking has taken her all over the United States, and she has given many radio interviews, including on NPR. Her scientific career includes a doctorate in zoology from Oxford University, many research projects in physiology, and a stint monitoring fish populations on the Bering Sea. More recently, you published a chapter titled Biology, Women, and Conservative Abrahamic Religions, A Bad Combination, and the 2018 book Women versus Religion, The Case Against Faith and for Freedom. As I mentioned, you are the co-author of the book Darwin's Apostles with the anthropologist David Ornstein, which will be coming out later this year in 2019. Mm-hmm. Your publications include No Data Required, Why Intelligent Design is Not Science. I'm seeing a thread here. And you published that in the American Biology Teacher. You have a chapter titled Intelligent Design Isn't Science and It Doesn't Even Try to Be Science in John Loftus's 2016 book, Christianity in the Light of Science. You have also contributed articles to the Humanist and the American Rationalist. You recently broadened your scope to include crushing the gender binary using biology, giving the same treatment to morality based on the supernatural. And currently you teach, besides all the public speaking and the book writing, you teach, is it just physiology or anatomy and physiology?
I teach human anatomy and physiology.
At Curry College?
At Curry College, yes.
Here in Bedford, Massachusetts?
In Milton.
Oh,
just
Milton,
down the street
Massachusetts.
in Milton.
You're from Bedford?
I live in Bedford, yes.
Okay, Abby, thank you so much for coming in.
Thanks for having me.
You're welcome. So I became familiar with you through the Committee for Skeptical Inquiry conference a couple of times, and I've seen several of your videos. And I'm getting this thread of the Not So Intelligent Designer. We'll talk about that in a minute, but let's just get a little background more on you. And I asked this just before we sat down, but can you define it again for me? So what is zoology? Because if I hear zoology and biology and physiology, to me they kind of all are the same thing. So there's this, zoology is something, you are a zoologist.
Well, I should say I have a doctorate in zoology. I've kind of broadened what I do since then because, you know, biology is a huge field, and the various different fields in biology do tend to sort of, you know, mush into one another. So yes, my DPhil is in zoology, which is the study of animals. But that can be anything from, you know, a single animal as an organism through animal behavior and even how animals interact with their environment. So that would be like behavioral ecology and things like that. All of those will fall within the remit of zoology, including things like even primates and primatology, so that the ape language experiments that have been done sometimes may have been done by zoologists. But basically, zoology is the study of animals.
Well, so it's a huge umbrella.
It's a huge umbrella.
With a lot
yes.
of sub-levels.
With a lot of sub-levels.
Kind of like physics.
Yeah.
You can say you get a doctorate in physics, but that doesn't really tell me much.
Right, right.
So.
And biology is an even bigger field because that is all life. So that includes things like biomolecules like DNA, for instance, but also proteins. Those are officially biology. But then that can go all the way up through cells and tissues and organisms. And again, biology includes the big stuff like ecology, which is sort of, you know, the whole environment as well. So biology is the really, really big field that then has all of these separate subfields.
So did you go into zoology, actually is that something you went into, or did you declare that path after you'd been exposed to other things?
Well, I mean, when I went to college, I went to a small college, Swarthmore College, where basically you majored in biology. That was what they had to offer. And you got a good core in biology as a whole, But I spent as much time as I could with the more organismal side of biology, that is to say, looking at plants, looking at animals, looking at things you can actually see, but then also looking at their interactions with the environment. So I was more on the organismal side, and I really, really wound up liking animal behavior, and that's definitely zoology.
Wow, I had no idea actually that animal behavior came under zoology.
Sure.
Wow. And so then you get a DPhil, that's what they call it at Oxford,
Right.
Doctorate of Philosophy.
Right.
And you immediately, was your goal to become a teacher, or did you want to do research or write, or?
Well, I kind of wanted to do all of those things, research and writing and teaching. And in academics, they tend to go together. And what I found actually was that much as I really liked the research, and at the time, the scientific writing was a little bit daunting, but I could do it, I discovered as I went along. Before I went to Oxford, I was a graduate student at UCLA. I did some teaching there. I did some teaching at Oxford as well. And I did find teaching very compelling. So I just found it was something interesting. I had had a really good undergraduate experience myself, and I think part of it was that I wanted to be able to give that to other people.
Well, let's get into the writing thing. So, was this your first book, The Not So Intelligent Designer?
Not So Intelligent Designer was my first actual book that I wrote myself. I did contribute a chapter to a book on chemical communication in animals, but that was a long time, and it was just basically one paper in a great big book. This one is my first actual book that I wrote myself.
And what year was this?
Oh, 2014 maybe. I had been working on it for a very long time.
And right away, the book, The Not So Intelligent Designer, the subtitle, Why Evolution Explains the Human Body and Intelligent Design Does Not, and Intelligent Design Does Not is in red.
Right.
So there's already when you see the book, there's kind of a statement right there. So,
Oh yeah.
So what happened in 2014, or it must have been earlier because it takes years to write a book, so you got riled about something.
Well, the way it works really is that I had been riled for a long time. When I was a graduate student at UCLA, and this was back in 1980 through 82, they were actually electing people to the school boards in Los Angeles at the time, and the school boards were voting to have creationism taught in biology classes in public schools.
Let's just take a step back so we can make sure everybody knows what we're talking about here. So you are you have a doctorate in zoology, and tell me something about what you know, if you can briefly do that, versus creationism. So creationism is a philosophy or a belief system. It's not a system of knowledge. Is that, I mean, how would you, so when you say people that were elected to the school board wanted to push creationism, what does that mean?
Okay.
Is that okay?
Okay, sure. No, this is sort of history of science stuff in a way, or rather history of anti-science. Because what happened was that during the 60s and 70s, religious people wanted to get religious ideas about biological origins wedged into public school science classes. And this, of course, is contrary to separation of church and state and also contrary to good science. But it's what they wanted to do. So they came up with this subject, and I'll say that in quotes, called creation science. And sometimes it was called scientific creationism. And the whole idea was that they were trying to explain biological origins, squaring the Bible with what we know about biology and claiming that it was science. And it was all the case of, we're starting with the Bible, now we're going to try and make it sound scientific. These folks are really good at sounding science-y, I guess is the way to put it. They don't do real scientific research. The evidence is not in their favor, but they've got an agenda. And the agenda is, we want to get religion into public schools. How are we going to do it? We're going to do it by questioning evolution. We're going to come up with our religious alternative called creationism, and we are going to wedge it into the public school science curricula. And they succeeded to the point where schools in Los Angeles were actually adopting creationism, President Reagan, when he was running for president, said that he thought that creationism ought to be taught alongside evolution in public school science classes. And creationism is rubbish. It is not scientific at all. They kind of use a few scientific terms to fool the innocent, but that's all that it really does. So creationism, as I said, was allowed to be taught in some public school districts in Los Angeles when I was a graduate student in Los Angeles in 1980. And I, in my innocence, back when I was an undergraduate, had thought that this had all been settled back with the Scopes trial in 1925. I didn't think that, anywhere out of maybe a few isolated people in Appalachia somewhere that evolution was even an issue. It turned out that even in one of the biggest cities in the country, it still was. And unfortunately, creationism was on the rise. It had a lot of powerful backers.
So let's talk 1 second before you go too much more. So
okay.
You said creationism is not science.
Correct.
Is it taking biology and trying to squeeze it into a prior belief system?
Yes.
So you're trying to make the data fit your opinion.
Right.
Okay. So it's just a religious philosophy then. You just have to get creationism out there because if you believe creationism, basically you believe maybe a young Earth, but the Noah and the thing, and that a creationist believes that man arrived on Earth approximately 6,000 years ago in our current form, and women.
Right.
I guess it was man first, right?
Right.
So that is creationism. We just, boom, appeared.
So
spontaneous generation from the supernatural.
Well, I'm sure that it was developed as carefully as they could with an eye to getting it into public schools.
But the basis is that creationism is supernatural intervention in
right.
life.
And in fact, creationism was declared to be religion by the Supreme Court in 1987.
Okay.
And at that point, intelligent design magically came into being at exactly the same time. It's not a coincidence. So what happened was that the creationists thought that they could start selling creationist textbooks, make a lot of money, all of this kind of thing. Creationism was declared to be religion and therefore not suitable to public schools in the United States, and that killed the creationism textbook market.
And it shuts it right down right away. If it's declared religion, it can't be in the schools.
It can't be in the schools, right. So the folks who were pushing creationism fell back, regrouped, and came up with intelligent design. It's just a strategic rebranding.
So you can teach comparative religion in school, right? You can take a class in religion and learn about many different religions, but the school can't push any particular version of it. So intelligent design comes up and it becomes an alternative
to evolution.
Okay, so then it's trying
They're again trying to get into public school science classes. They're trying to say that this is legitimate science, which it just isn't.
So like a comparative science class, comparing evolution versus intelligent design.
Well, no, they just want it in science classes. Basically what they want to do is say, okay, the opinions on evolution are not settled. It is not settled science. And here's this other thing that we have that is just as legitimate a scientific explanation of biological origins as evolution. So we have to teach both of them. That's what they are trying to push.
Okay.
It would be like if the flat earthers, and we've heard a bit about flat earthers recently.
Yeah, oddly.
Oddly, yes. This is kind of a good sort of way of looking at it. We all know the flat earthers are wrong. The Earth is roughly a sphere. That's where all the evidence is. Our maps wouldn't work without its being a globe. GPS wouldn't work without the Earth being a globe, and so on. Nonetheless, you have people who will argue very vehemently that the Earth is flat. Now, in a public school science class, you should not teach that, well, some people say the Earth is flat, some people say the Earth is a globe. You decide. We don't do that. We teach children that the Earth is a globe because that's the good science. And, people have a hard enough time understanding science as it is without confusing people saying, oh, well, here's this alternative stuff that is equally true when it's not equally true.
I want to back up. Well, I don't know if I'm backing up or going forward. So if we're talking about evolution, part of the bugaboo is that it's called the theory of evolution, but can you define, in scientific terms, theory of evolution isn't like I have a theory about why my car didn't start.
Yeah, okay. Yeah, in common English, we use the word theory to mean I've got an idea. I think I know what's going on. I have a hunch, basically. And in fact, the way that people opposed to evolution will use it is to make theory sound like sort of something even less than an idea. But a theory in science is this huge model that explains lots of things, and one of the things that a theory has to do is generate testable hypotheses. That is to say, smaller ideas of how you think some small thing will work, where you can actually generate a prediction and test that prediction using observations, using experiments, whatever. And a theory should generate testable predictions. If you cannot test something, then by definition, it is not a theory. And so, for instance, intelligent design cannot predict anything. It cannot be tested. It is not a theory. So whereas a theory in science is something like gravity. Did you know that gravity is a theory?
I did know that, yes.
Okay. Now, that does not mean that we are going to go on the roof of the building and say, oh, gravity is just a theory, so we can safely ignore it and walk off the roof of the building. We don't do that. We know better, because gravity is real. Gravity is true. Gravity generates testable hypotheses. If I take that water bottle and I drop it from a certain height, I can tell you exactly when it's going to hit the ground, because we have thoroughly studied gravity. In the same way, we have thoroughly studied evolution. It generates lots of testable hypotheses. The hypotheses have been tested. Evolution's there.
If we go to intelligent design, then, what's their theory? You must know what the argument is.
Their idea, it's not a theory.
Okay, good, good.
Their idea is that the human body is so perfect that it could not possibly have come about through evolution, that there is evidence of an intelligent designer. And they deliberately leave it vague because they got stung by the whole creationism thing being declared religion. So they leave the word God out of intelligent design. God winds up being in all of the intelligent design promoters' writings, mind you. But at least the words intelligent design don't include the word God. They're very careful to say a designer.
Okay, an intelligent.
An intelligent designer. So, I teach human anatomy and physiology. Getting back to what I was saying earlier on, remember how I was saying that back when I was a graduate student in the 1980s, creationism was being taught in American public schools in Los Angeles, as well as other places, and I was appalled, but there was nothing I could do about it. I was a graduate student at the time. I had a degree to get. I had other things to do. But it was appalling. So I came back from Oxford years later, and I started my career and so on, and it hadn't gone away. It had gotten changed from creationism to intelligent design, but it was still making headway in the United States, and this was appalling to me. And what I discovered was that it's completely political. I mean, it makes sense when you think about it. Scientists do not think that intelligent design is correct. Scientists, like 99% of all scientists, accept the evidence for evolution. So why is it continuing? Why is intelligent design continuing to be an issue? And it is because there are powerful religious and political figures who want it to be an issue.
Right, so you have said it's a political argument, it's not a scientific argument.
So it is entirely political. Intelligent design is something that powerful religious and political figures are pushing for their own reasons. It is not being pushed by scientists. It is certainly not being pushed by biologists. So the evidence, the scientific evidence, is all in favor of evolution, but the problem is that most people don't know it. Most people are not biologists. You're not a biologist. So, I realized that science had done a poor job at communicating all the evidence for evolution. There is so much evidence for evolution. We have libraries full of evidence for evolution, and most people don't know it. So I gave myself the assignment of, well, what kinds of arguments could be made? Political arguments are different. If evolution is going to be dragged into the political arena, which is what has happened, how are you going to make political style arguments for evolution? I've worked on political campaigns, and political campaigns are all about messaging. They're all about talking points. There may be a ton of good, deep policy work involved in politics, but you have to be able to make it fit on a poster. You have to be able to make it fit into a soundbite. You have to be able to make political arguments that are short and easy to understand, easy to remember, easy to repeat. That's the kind of thing you want for a political argument. This is not the way that scientists are taught to talk. So I gave myself an assignment of what would a political argument for evolution even look like?
Yeah, that's what I was just thinking.
So I just gave it to myself as sort of a thought assignment. No deadline or anything like that, just to mull it over. And what happened was that there was one day when I was actually in an anatomy and physiology lecture, and we were lecturing about human reproductive systems. And I had just put the male reproductive system on the board, and I was talking about how the testicles hang outside the body. And so I asked, does anybody know why the testicles hang outside the body? There's usually somebody who knows. So, I asked for, hands raised and so on, and sure enough, somebody knew the reason why men's testicles hang outside the body is that the testicles actually have to be slightly cooler than normal body temperature in order to produce viable sperm. So I turned around, I was writing this on the board, and as I was writing it on the board, I thought, that's really dumb. Who thought of that? And it's bad design, I'm telling you, because men are put to all sorts of inconvenience and they risk severe pain and worse because of this really bad positioning. So who came up with the idea that normal body temperature was incompatible with sperm production? I mean, that's just dumb. You got to admit that.
Not so intelligent.
So I thought, okay, this was definitely not done by any intelligent creator. And this is my first best argument against intelligent design in the human body, because once I start talking about men's testicles, people will pay attention.
And there is no biblical verse like for women menstruating. There's no biblical verse that says, "And you shall be cursed with your testicles outside of the body from here until the sons of the generation."
That's true.
If that were in the Bible.
Right. And supposedly we were made in God's image. So, presumably we should have, gotten the best of everything.
And that's just one little thing. So we're getting into it now. So not so intelligent designer.
Right. Yeah, as I said, men's testicles are really a good place to start because men really identify with it. And it's kind of obvious. It's like, yeah, why should they be outside? Why couldn't sperm making and normal body temperature be compatible? And the argument becomes more compelling when you realize that there are other animals that do have warm body temperature and they have internal testes. All birds have internal testes. You've never seen balls on a turkey. You've probably had many, Thanksgiving turkeys. You've never seen the balls. Birds' testes are on the inside.
And whales too, right?
And whales, that's right. All marine mammals, various other mammals actually have internal testes as well. Rhinoceroses and elephants have internal testes. So you kind of have to ask why, great big dangerous rhinoceroses got internal testes, but relatively vulnerable human men did not get internal testes. It doesn't seem fair, but it's also kind of proof of concept. It is possible to have warm body temperature and internal testes, but we didn't get it. Now, as I said, maybe God just likes elephant better than humans. Or if you go with the bird hypothesis, maybe God is a turkey. In fact, remember, somebody was made in God's image according to the Bible. And if turkeys got a better design than humans, does that mean God is a turkey? I mean, you can go all kinds of places with this particular argument, but what it really shows is that God didn't design the human body because nobody designed the human body.
So they need to be on the outside for temperature regulation.
Right.
Okay, that's just the way it is.
They need to be on the outside because men's testes have to be slightly cooler than
humans.
normal body
Yeah, men,
temperature.
Okay. So what's the, have you, not you personally, but is there a chain back to when that happened?
Oh yeah.
So what, okay, so who
There's
was
been
the
lots of research done
who was
on
the
this.
greatest species that says, you know what, I'm going to hang these things on the outside?
Okay, what happened is
I
that
hope I phrased that correctly.
way back in vertebrate history, before we started doing temperature regulation,
I'm assuming they all started on the inside.
they all started on the inside.
Okay.
If you did like a frog dissection in high school, you may remember that the frog's testes were on the inside. If you don't, that's okay, but they are anyway. So yes, testes started out on the inside. But when you have a cold body temperature like a frog, it doesn't really matter anyway. So then at various times in evolution, the business of becoming warm-blooded kind of came up. And the easy solution to that is indeed that if testes are a little bit nearer the outside, they stay a little bit cooler, just because they're nearer the outside.
So they just kind of start moving to the outside.
So they start moving to the outside.
And you can see that in some species where they're in the middle of this thing and then, oh, they're closer to the edge here.
I can't comment on that,
Okay.
but you know, this is what would make sense. But on the other hand, it didn't happen in all species, and interestingly, in some cases they moved back, like for cetaceans, whales and porpoises and
Right,
things
of course,
like
because
that.
a whale is a mammal, so you can't be all mammals.
Right. But therefore, what happened there was that what was heavily selected for was the sort of smooth whale body shape.
Okay, yeah,
and the
right.
testes went back in. It's just that we didn't get that. But as I said, it's because we evolved, and the standard for evolution is good enough to not cause death before reproduction too much of the time. Whereas the standard for intelligent design is designed by an infallible creator. And human bodies just really do not measure up to the infallible creator benchmark, whereas we certainly do meet, usually, the benchmark for good enough to not cause death before reproduction too much of the time. So that's why we have all sorts of imperfect body parts that should not exist in a designed system, but exist perfectly well in an evolved one. Does that make sense?
It does, well, perfectly well in an evolved one. Meaning
In
that
an evolved, they are good enough. It's a low standard.
Yeah, just to
As I
get to the
said,
next level.
Good enough to not cause death too much of the time
I remember,
before reproduction.
where was I? I was working, I'm a musician, I was working at a gig someplace and a thunderstorm came by and lightning struck really nearby. And it, you know, it was scary. And some person said, well, a miss is a miss no matter how close it is. So in terms of evolution, a hit is a hit no matter how inefficient it is.
Right.
Does that
That's
make
right.
I hope that
That's
makes
right.
some kind of sense.
As long as,
It just gets you to the next-
individuals reproduce, the species keeps going, and that's all that evolution is.
Well, it's like that old joke about two guys and the tiger. You just have to run faster than the other guy.
Yeah, right.
Right?
Exactly.
So you just have to evolve a little bit enough to beat out your neighbor.
Right, or have the right combination of genes that you're moderately successful. You don't even have to beat out your neighbor, you just have to reproduce, basically.
All right, so let's get off of men for a second. There must be something wrong with women. Can you tell me anything about the vagina?
Oh, the whole birth canal thing.
Okay.
Any woman can tell you that birth canal is just not big enough. And the thing is, that actually is deadly. In the days before modern medicine, lots of women died in childbirth. It was pretty routine. In colonial New England, women frequently wrote their wills before they went into labor.
No kidding.
Yeah.
Oh, wow.
So it's a dangerous process, and you know, today we have cesarean sections. They're being done in ever increasing numbers, and part of the reason for that is just that giving birth is dangerous.
So it's risk management. Well, what I'm saying, I don't mean to put it that way, but okay, I didn't realize.
A C-section is dangerous
Yeah, right.
because it's actually surgery, but on the other hand, giving birth
It's a little more controlled, I guess.
is damaging and sometimes fatal to
Okay.
either the woman or the baby or both. So you know, that's just not a good design. If you ever take a look at a human pelvis, the birth canal is really pretty narrow, and we give birth to big-headed babies. It is not a good fit. And this is where looking at counterexamples can really come in handy.
So humans, bad design, but there are examples of good design.
It goes like this. The sort of problem from an engineering standpoint for human babies and human women is that we walk on two legs and we are very smart. Now, being very smart requires large brains, which requires large heads. We give birth to large-headed babies. On the other hand, walking upright, walking on two legs favors narrow hips. If somebody's hips are too wide, they really cannot walk well. They cannot run well. So women's hips are sort of an uneasy compromise between being able to walk and run up, you know, on two legs on the one hand and giving birth to large-headed babies on the other hand. It's an uneasy compromise. It's not a good solution. It's the best we've got, basically, for humans. On the other hand, if you were an engineer and you were just starting with those specifications, walk upright, gives us hands, you know, this kind of thing. Walk upright, very smart. How would you design it if you were just starting with those specifications and a whiteboard and you were brainstorming designs? You could come up with something like what kangaroos do.
Oh, back to kangaroos.
Kangaroos hop on two legs, they're bipeds, and they give birth to very small embryo-sized young that then finish their development on the outside of the mother's body in a pouch. You've seen those kangaroo pouches, you've heard of them.
Yeah.
They actually have nipples in them. And so there will be this tiny little embryo known as a joey that winds up in the mother's pouch. That's where they continue their development, and they eventually get out when they are old enough to hop around on their own.
So it's an embryo in the pouch.
It's basically an embryo.
Oh,
yeah.
okay.
Mm-hmm. And, you know, there's no particular reason why, as I said, if it had started as an engineering project, why we couldn't have done that. You know, just take the embryo out, stick it in a pouch on the outside. Now we don't have to worry about labor pains. Now we don't have to worry about...
And when it's ready, it's ready.
And when it's ready, it's ready. Exactly. We don't have, you know, we wouldn't have, or we don't, as it is, the way we give birth, we have to worry about all kinds of problems having to do with the embryo before it's born, inhaling various amniotic substances, including waste products. You have to worry about getting the head through that bony pelvis, which is just not big enough. There are lots of problems that can come up, which, you know, are kind of solved by having the embryo in the pouch routine.
Well, I came out ass first, so...
And that's a problem, too, because you might have actually died from lack of oxygen.
Yeah, they fixed it, so...
Good.
You know, but so...
Right, but
if it's not, if your head isn't the problem, you can get twisted up inside.
But in nature, as I said, you probably wouldn't have gotten turned around.
Right, not if it had been maybe 400 years ago, I don't know.
Right, 400 years ago, you probably wouldn't have been turned around. That's modern medicine for you.
Now...
Is this making sense?
Yeah, it's making sense. I mean, I'm sure there are dozens and dozens of other examples of...
Oh, there's heaps of examples. One that is perhaps a bit more G-rated that you can use, you know, if you're visiting your kid's fourth grade class or this kind of thing, or talking to your local legislator or school board or whatever, is the two tubes in your throat. Everybody has this experience where at some point or another you've inhaled a gnat or you've inhaled cracker crumbs or something like that. Point is, we've got two tubes in our throat. One is for breathing. The other one is the esophagus leading to the stomach, which is for food and water. But they both have a common origin at the mouth and in this area sort of here called the pharynx. So there's this common opening here for the pharynx. Food passes through it. Water passes through it. Air passes through it. When you are swallowing, there's a flap that actually folds over the air passage, which is in the front, so that the food and water are directed back into the esophagus leading to the stomach. But on the other hand, if you are just eating and talking, Maybe you're having a really good conversation and you inhale when there's food in your mouth, and that food can get vacuumed into your windpipe.
Yeah, we've all had that happen.
We've all had that happen, and the problem is that can be fatal. If you inhale a large enough piece of food into your windpipe, a steak, a hot dog, something like that, that can actually block breathing, and you can die of suffocation very, very quickly. That's why the Heimlich maneuver was invented, which is this business of sort of going behind somebody and doing this. That was invented because lots and lots of people otherwise die from inhaling a piece of food and having it get stuck there. And that is because we are badly designed. I mean, who thought of having the food pipe and the air pipe, on which we depend for life, having a common entrance like that? It's just bad design. It shouldn't have been done that way.
If it were designed, it would be bad design.
Right. If it were designed, it would be bad design. Not evidence of an infallible creator, especially, once again, there's the counter element, the counter evidence. Whales have completely separate respiratory systems and digestive systems. A whale's blowhole, you've presumably seen a whale's blowhole. That is actually its nostrils.
Right.
So it's the whale's respiratory system is completely separate from its digestive system. So again, this is proof of concept. The creator, if there is one, gave the better version of that equipment to whales than to us. We have this really obvious flaw that could be fixed pretty easily, but we didn't get that, and that is not the sign of an intelligent designer. Is that making sense?
Oh, it makes perfect sense.
Yeah.
I'm trying to be contrarian here, but I can't, just to.
Oh, sure. But
But
the point is, but this is one that's pretty easy. You can talk to a fourth grade class about something like that. Although, if you are ever stuck with a school board that wants to adopt intelligent design, well, then you can go to the meeting and say, well, if we're so well designed, then why do men's testicles hang on the outside, whereas a whale's testicles are on the inside? Because I guarantee you that will get people's attention.
Blasphemer.
Right.
You're questioning the intelligence of the almighty supreme being.
Oh, well, then you're not talking science, and then it's right out of public schools.
Right, so if somebody were.
Oh, somebody brings up religion, you've got them right then and there in terms of public schools. They may think they are correct, but it cannot be taught in public schools if it's religion, because we have constitutionally provided separation of church and state in this country. So that's the end of that. It's also bad science. It's not science if you bring up religion, because science specifically does not entertain ideas about the supernatural. Because ideas about the supernatural, or when I say entertain ideas, it will not accept a supernatural explanation for any natural phenomenon. Because we have found over the 400 years that modern science has existed, that if you do not allow supernatural explanations for things, then you go looking for the real explanation for things and you find it.
So don't give up and say.
It works every time.
So don't say, I don't understand it, so it must be God.
So it must be God, right. As soon as you bring in God, that's a real research stopper. And the problem is that when we reject supernatural explanations, we find the real explanations. I mean, the AIDS crisis is a good example of that. Lots of people wanted to jump on the bandwagon saying, oh, AIDS is a sign from God that AIDS disapproves of the gay lifestyle and all of this kind of thing. Lots of people wanted to jump on the bandwagon of the idea that AIDS was divine retribution for something or other, and we didn't know where it came from and all this kind of thing. Well, of course, we didn't know where it came from. It was a new disease. New diseases, by the way, are great evidence for evolution. So we had this new disease on our hands, and scientists rejected supernatural explanations, which meant that we discovered HIV, the human immunodeficiency virus. And of course, AIDS is now treatable. AIDS would never have been treatable if we had simply accepted that it was divine retribution.
Because you would just give up right there.
You just give up right there.
Nothing we can do about that.
Nothing we can do about that.
Just have to pray a little bit more or something.
Right. So if anybody who has ever taken antibiotics or used modern medicine or anything like that, they are accepting science whether they like it or not.
If you can, I want to get onto your science bill, which you have before hopefully it will be before the Mass State Legislature. But before we do that, there's always a couple of objections that come up, and if you can dispel them quickly, that'd be great. I can't believe in something that's random, and what about all the missing links?
Okay, randomness.
It's not random.
Well, here's the thing that's interesting. Mutation is random.
Okay.
Mutation is simply a slight genetic change. And when you have a slight genetic change in your reproductive cells, your sperm or your eggs, then that is handed on to the next generation. If you get a random mutation in any of your other cells, you may wind up getting cancer. But the point is, mutations are just, breaks in the DNA or some change in the DNA. We don't have control over that. Well, no, actually, these days we have gene editing. But in terms of evolution, mutations are random.
And so a mutation by itself is neutral. It could be good, it could be bad.
It's just something that happens.
Just something that happens.
It's just something that happens. Most mutations are bad. But then on the other hand, if you have those mutations, you likely don't live. And so that's the end of that. A lot of mutated embryos will die in utero if the mutation is, large enough and important enough. But there are a lot of small mutations that will just be passed on to the next generation, and then there they are. So as I said, mutations are random. But then after that, you have all of these selective pressures, both good and bad. And so at that point, you are getting natural selection working on whatever genetic component an individual has. And I need to put in a word here as well for genetic diversity. In any given population, you will have people with different genetic components. In the same way, some people have brown eyes, some people have blue eyes, some people have red hair, some people have black hair, and so on and so forth. There's a lot of genetic diversity in any given population. And this is good because it means that whatever external threat comes down the pike at us, there are probably some individuals that have the right combination of genetics already to survive a little bit better. And so they are the ones that are more likely to live, the ones that are more likely to reproduce. And so, that population will then go in a certain direction. But it is the genetic diversity which is fed by mutation. We wind up with more genetic diversity by way of these mutations, and then you have selection, which is usually external events. It will be, a change in climate. It'll be an ice age, something like that. What things survive an ice age, what things do not survive an ice age. Is this making more sense?
Yeah. So, and a bad mutation won't get selected for, especially if it dies in utero.
Yeah,
or
if it dies in utero,
forward.
or if you die before you reproduce, that mutation is gone. Right.
All right, now missing links.
Okay,
I'm not even going to be very specific here. I'm just going to say,
Yeah, well, the thing that's funny about that is that it's kind of a funny thing to bring up when you think about it, because we've really only been carefully studying fossils since the late 1700s. So let's see, we have, the 1800s and the 1900s, and we're a little bit now into the 2000s. So it's like 220 years that we've been really paying attention to fossils. You really think we're going to find every form of life that has ever existed on Earth? Life on Earth started 4.5 billion years ago. And fossils just sort of happen, again, kind of at random, where something gets buried and properly preserved and all this kind of thing. They're scattered all over the globe. Some of them are deep, some of them are shallow. And what gets fossilized is going to be, a matter of chance anyway. It's kind of weird that scientists would have been expected in the 150 odd years since evolution has been around as an idea, sort of a well thought out idea. It's kind of odd to think that in the past 150 years, we would have found every single fossil that ever existed on Earth. I mean, come on, that's asking a lot.
Well, it's asking a lot that every single link would be fossilized, I think.
Exactly. So there's that. And of course, we keep finding more fossils. And of course, fossil evidence is not the only evidence for evolution by a long shot. So, the fossil evidence is cool. And nothing is more fun than a good dinosaur. But on the other hand, fossil evidence is far from being the only evidence we've got. And I mean, the fact that dinosaurs existed, think of all those dinosaurs, fabulous creatures, wonderful creatures. Where are they now? I mean, they're birds. Birds are evolved from dinosaurs. But, on the other hand, isn't that kind of a good argument for evolution? If all of these dinosaurs were created by God, did God just kind of decide at some point, oh, I'm tired of dinosaurs, wipe them all out, except for the ones that evolve into birds?
Well, possibly.
I mean, possibly, but again, that's not sort of your all-loving, intelligent God. Again, that's kind of, more God as the very bad-tempered child who plays with some toys for a while and then gets tired of them.
So we've talked a lot about the not-so-intelligent designer. We didn't really get to Darwin's apostles yet, but I want to make sure we get to your science bill that's coming up before Massachusetts, and I have a copy here. So it's not very long, actually, because it's an insertion into the general laws as they stand now. So do you mind if I read this?
Right. This is a science bill which is current, or I should say it's a bill.
It's not a bill yet. It's a, whatever they call it. It's a House docket number. It will be a bill.
It will
be an act relative.
It's an act relative. Anyway, it's in the legislature. Right.
Okay, so it reads...
In Massachusetts.
An act relative to science curriculum standards. The proposal is to hereby amend Section 1D of Chapter 69 by inserting in line 31 after the word states the following. So this is your part. The standards for the subject of science shall include only peer-reviewed and age-appropriate subject matter, provided 1. Peer-reviewed subject matter shall be defined as conducted in compliance with accepted scientific methods, and 2. Age-appropriate shall be defined as topics, messages, and teaching methods suitable to particular ages or age groups of children and adolescents based on developing cognitive, emotional, and behavioral capacity typical for the age or age group. So I'm assuming you think this is important to insert. And
I
why
think this
is
is
that?
important
What's
to insert.
missing?
Okay, what's going on here is
Do you see a threat on the horizon, really?
I don't see a threat on the horizon in Massachusetts necessarily, but you never know.
Right, okay.
So it's sort of a prophylactic in Massachusetts because there are people in Massachusetts who want to teach creationism or intelligent design. And in fact, I helped out my local representative, Ken Gordon, with at one point his opponent thought that teaching creationism and intelligent design in Massachusetts public schools was a perfectly fine idea. So those ideas do exist in Massachusetts. And I would say we are not in danger now, but with politics, anything can happen. So I thought it was a good idea to have this sort of as a safety measure in our laws ahead of time, so that if some town decides, gets a school committee where they say, oh, let's teach intelligent design along with evolution, we can pull out the law and say, no, you can't do that because intelligent design and creationism are not peer-reviewed science. So as I said, this is kind of a safety measure, but the other thing that it does is it's political. The whole point is what the promoters of creationism and intelligent design do is they have sample legislation. If you go to their websites, they will say, here's how to word the law that you can get it passed. And that is why both Louisiana and Tennessee currently have laws on their books saying that you can teach intelligent design and creationism in public schools in Louisiana and Tennessee. And the laws are worded very carefully, but there they are. And so but as I said, it was done because the powers in that field came up with sample legislation that could then be copied.
Right.
So my idea is if we get the bill passed here, then that is the sample legislation that can be used in other states, so that other states that want to protect their science education can then pass bills like that. So I'm hoping that, as these things go, it should be a relatively easy lift in Massachusetts, but once passed in Massachusetts, it can be adopted elsewhere. Now, when I say a relatively easy lift, nothing is easy in terms of legislation ever.
Right, I suppose the more publicity you get, the harder it might be. You might
Possibly harder, possibly easier. We need all the help we can get, always. That's just the truth in politics. But I'm hoping, therefore, to get the bill passed here because it will be good for us, but it will also serve as sample legislation for other states that may want to adopt it. And, you know, it's kind of a hopeful idea, like same-sex marriage. It was adopted in Massachusetts first. Now it's the law of the land. What happened in between was it was adopted here. A few other states kind of crept up to it, and it was adopted in one other state, and 2 and 3, and it was this very slow progress, and then it was adopted nationally. And so, you know, progress can go in the correct direction, but you have to start somewhere.
Well, and you're making the case that if you get your paragraph, then it becomes a template.
Then it becomes a template,
like
right, that
ID.
other states can use, and possibly even the nation could use.
Now, you're also dealing with people that might say we don't need, just basically we don't need to do any meddling because we already have a code written. And you're dealing with, you know, you have to convince legislators, their job is politics and legislation. It's
Right.
not science, it's not teaching. So they rely on expertise. Sometimes, I shouldn't say lobbyists or expertise, but they get information from other sources. So how do you
Of
make sure
course.
that you're giving them the correct information in a palatable way, I guess I should say.
I don't quite understand your question.
I guess I'm saying they're not scientists.
No, they're not.
So you have to, and you have to dumb it down for me, and I don't think it's a bad thing to say you have to represent it in a way that people understand that this needs to be done.
No, that's absolutely important, absolutely. But what people, actually in Massachusetts, it's a relatively easy sell because in Massachusetts, we have so much of our industries based on science.
Right.
People really care about education in Massachusetts, and they, generally speaking, really care about science in Massachusetts. When I've been out canvassing, again for my local representative, if I told the people I was going up to their doors, if I told them that the opponent was in favor of intelligent design and creationism, which he had stated on record, so I wasn't making things up, they would immediately say, ooh,
They
no,
all knew what that meant.
education. And if they don't, you can say, but the point is, at that point, voters will vote in favor of science. We know that science does us good here in Massachusetts. Doubtless there are naysayers, but the point is, in general, the Massachusetts population knows that science is a good thing, and they care about science education because, you know, we have a lot of people who want to go into science or want to go into medicine or health or anything like that. So they really care about quality science education. And the idea that some of this nonsense might be slipped in, muddying the water for their children, is really important. And I can say, I've taught in community colleges. And in community colleges, what you often see is that even well-motivated students who are wonderful, they're adults, they want to get ahead, you know, if they don't have a good background from their high school and their elementary school educations, if they don't have a good background in science, they really struggle. Now imagine if instead of merely having to make up for whatever you didn't learn in high school as you're taking, you know, my anatomy and physiology course because you want to become a nurse or you want to become a physician's assistant or something like that. You're already struggling because maybe your background in science wasn't that great. Now imagine that in your high school and elementary school, you were taught something completely different. You were taught creationism. You don't just have to fill in the gaps in your knowledge in that case. You actually have to unlearn everything that you learned and learn the stuff that you should have learned, all while keeping up with a college course. It's too much to ask of people. They're not going to make it. I can tell you that as somebody who has taught in a community college. Those people will not make it. And so actually this is a social justice issue because people who do not get good backgrounds in science, and particularly people who wind up being confused about science, they are the ones who are not going to be able to take any of the avenues into the middle class that are provided by either science or health care. If you want to become a nurse, you need to have had a decent science education in high school, or you need to do a whole lot of reading ahead of time, you know, before taking a course like anatomy and physiology, which is taught to first-year college students, and it's a gateway to all of the health professions. If you cannot pass anatomy and physiology, you do not have a way into the health professions in a way that will actually give you a middle-class life. So this really is a social justice issue as well as a scientific one.
So if people want to get more involved in, you know, contacting the legislators and saying this is up for, I guess it's in committee right now, or however they do it, I'm not sure what the process is. If you want to make sure that this gets pushed a little bit along, do you have a website to reach out to you? Just look this up. What do you suggest people do?
Yeah, I don't have a website at this point. This is something that I'm hoping to develop this summer so that people could just go there and find it. Right now, it is in the Massachusetts legislature. I think if you read that thing
I'll put it up.
it has a docket number at this point.
So just call your legislature.
You can follow it online if you go to like massachusettsmass.gov and go to the legislature. You can then find the docket number and you can follow along what's happening to it that way. Eventually it should get a bill number.
Right, yes, hopefully.
Hopefully, right.
All right, Abby Hafer, this is 502 Conversations. I'm Brian Kirby. My guest today has been Abby Hafer, best-selling author, The Not-So-Intelligent Designer, Why Evolution Explains the Human Body and Intelligent Design Does Not. And your new book coming out is Darwin's Apostles.
Right.
You have a bill hopefully up in front of the, it's in committee right now. Hopefully it'll get a docket number and be processed through and added to our general laws.
Right, it does have a docket number. It does not yet have a bill number.
Okay, yeah, I'm confused about how the process works.
Right,
so.
right.
But thank you very much for being here. We had so much more to talk about. We kind of got bogged down in evolution, but I hope that's okay with you.
That's okay with me, yes.
Thank you very much.
Well, thank you very much.
You're welcome.